Cisco Certified Network Associate Day 25. Welcome back everybody, I'm Imran Rafai, your trainer for this entire series. Today we're going to learn about IPv6 Advanced, and when I say advanced, we would be learning a little more advanced topics than what we learned in our last video. Since this video is going to be slightly long, let's not waste much time. Let's get straight into today's class. But before I do that, let me put on the screen some of our social media links, and this is where you should be able to contact us for all your queries. And pause this video for a second, hit that subscribe button and subscribe to us, and we would be getting many more beautiful video series in IT, right? So let's get straight to today's class. We're going to look at three things. Like always, IP version 6 auto configuration, IPv6 configuration and troubleshooting, and we will look at IPv6 routing basics, where we will look at some static routing and RIP NG or RIP next generation routing. So like we learned in our last video, IPv4 has an auto configuration IP address known as APIPA, or automatic private IP address, right? So this is the IP address that starts with 169.254x and x, right? Like we discussed in our last video, whenever there is a DHCP client, right, connected, and it is configured for automatic DHCP IP addressing, and if there is no response from the DHCP server, it has the ability to give itself an IP address, and that IP address will start with 169.254, and then it will take 2 octets of random numbers, right? Now if there is another device, that also will go through that, and every time it assigns an IP address or the API address, it would send a broadcast, and if at all the broadcast replies and tells there is nobody else with that IP address, it will accept that IP address, and if there is somebody else with that IP address, they would generate a new API address, right? So let's look at this in Packet Tracer to understand what I mean by this. Right, so I have put a PC, and I'm going to IP configuration, and I'm going to make IPv4. Now this is IPv4 and IPv6, so I'm going to make IPv4 into DHCP, and now it is trying to request an IP address, and like you know, there's nothing else connected. There's no DHCP server who can assign it an IP address, so obviously it will not get a DHCP reply, and it will have to configure itself with an API address or the APIPA address. We can verify that by doing ipconfig, and it will tell me, right, it still hasn't connected. I think you might have to, let me do that again. Right, so I think you might have to put a switch. So let me do this. Let me put a switch, and let me connect it so the connection works to the switch. And I think what it will do now, it will it's in DHCP, so it should technically give itself an IP address. Right, see, if you see that, it has given itself an IP address, because obviously the switch starts communicating, and then this device realizes that it is not getting any response from the switch, because the switch is not configured for DHCP server, so there's no DHCP server connected to the switch as well. So it gives itself an IP address 169.254, and then it chooses 2 random numbers for the 3rd and the 4th octet, so 26.192. So it has this IP address. Now the reason this IP address is there, or this provision is there for these DHCP client, is that if, let's say, you are in a local network and you have devices that is configured for automatic IP addresses, almost all the devices, Windows devices, are by default configured for automatic assignment of IP address, right? So if it connects to a network, now you connect these new devices, let's say you buy 5 computers and you connect all of them to the switch, and there is no DHCP server in the network, these devices can give itself an IP address. And let's say we give another device here, and we connect it as well to the switch, and we go to this device and let us change it to DHCP, right? So it also will do the same thing. It will give itself an IP address, right? If you can see, it has given itself an IP address in that API range, that is 169.254 and 167.182. So you can see it's random number. The PC1 or PC0 in this case and PC1, both of them have IP addresses. The 3rd and 4th octet are absolutely different ranges, but these are /16 right, /16. That means to say it is these both technically should be able to communicate with each other. So let's try that. I say ping 169.254.26.192, and there it is replying. That means to say these two devices are communicating. So if somebody has not watched our IPv4 video and assuming that they have no idea of what IP addresses are and what subnetting is and all those technical aspects, they can still connect to computers and they can look at the IP address by putting this command ipconfig. I mean, ipconfig is a very simple command. Most of us know how to look at IP addresses. So by just looking at that ipconfig, they can technically start configuring these two devices. So you could have a share folder in this device where you can go to this device and use that IP address and configure that share folder to be accessed in this computer, right? So all these things can happen without having any knowledge of how to configure IP addresses. That is APIPA, right? So that's IP version 4. Now IP version 6 also has auto configuration. So one thing, the main difference, I don't know if I said this in the last video, is IPv4 and IPv6 has one critical difference, and that difference is IPv4, let's say if you assign an IP address to a router, so let's say this is the router, and if you assign an IP address anything XYZ, whatever, right, 4 octets of IPv4 address, and if you go to that interface again and say IP address and you give a totally new address, the last address that you give is going to be updated. That means the address that you gave first is going to be overwritten by the address that you give second, right? That is what is different in IPv6, where IPv6 interfaces can have multiple IP addresses. Yes, I know the exception to that rule is in IPv4 you could give a secondary IP address, so you can say IP address and you give an IP address and give the command secondary, which means to say that IP address is used as a secondary IP address, but for all practical purpose the primary IP address is what is going to be used for everything, right? But in IPv6 you don't have to do that. So you say I'll in the next slide we'll show you how to configure the IP address, but just know that if you configure a second IP address on the same interface, both IP addresses are going to be in that router, right? So that our router will have access to both those IP addresses. So whenever you give an IP address to an interface in a router or any of IPv6 enabled devices, it would automatically give itself, let's say you're giving this IP address /64, this is an IP address that you're giving to this interface, automatically it would create a link local address. Now remember from our, if you remember from our last video, link local is something that is auto generated by the device or by that interface, and that address starts from FE80. Remember, FE80. So anything with FE80 is a link local address. That means to say that address is significant only to that interface. It would not be able to communicate outside that segment or that interface. And like we discussed in the last video, it makes use of a MAC address, and it pads, because MAC address is a 48-bit address. It pads FFFE in the middle to form a 64-bit number or 64-bit address, which becomes the host part, right? Now this is also known as EUI64 format, right? EUI is it is EUI64. EUI64 is an IEEE standard. And IEEE, if you know, it is a standard organization, right, which does a lot of standardization process to the networking world and a lot of IT and computer world. So EUI64 is a format which takes addresses, pads it, and creates a 64-bit number. Ideally, in IPv version 6 scenario, it takes the MAC address, right? So it creates a unique identifier by taking that MAC address, because MAC address is a unique identifier, like we all know, and it adds FFFE in between and creates that, right? So that is the automatic link local configuration. I think we'll go to packet tracer. We'll look at this first, and then we'll come back and talk about the other points in this page, right? So we configured these two devices, if you remember, and if you look at this part, right, when we just assigned it, or rather the API PA assigned it an address, right? It assigned it an address, and if you see, it already has a link local address to it, FE80 address. Now FE80 address, right, even technically it gets generated if an IPv6 address is assigned. So if we give a IPv6 DHCP, you see that link local is already there. Now how is link local taken into consideration, or how the link local is generated, is like we discussed, FE80 : that means this whole part is the network part, and these 4 blocks of hexadecimal numbers are the host part, right? So 2EO8, and if you can see here, FE has been added in between to make use of this. So this device has a MAC address of 2EO8F5A1ACO, right? Or rather, it would be starting with 02EO, right? So this is a link local address, and this is automatically configured, and this part is the EUI64 format, right? EUI64 takes use of, like I said, it takes the MAC address, it adds FFFE and creates that 64 bit address, right? That is the EUI64, and this link local is configured using link local. Now the question is this: can we assign link local manually? Absolutely yes, we can configure link local manually. So let's do this. Let us take a router, right? So let's do a little bit of Cisco stuff. We will come back to the switches, all these hosts a little later, but let's get in here, and I'm gonna assign these addresses, right? So it says, let's say no, enter, configure terminal, and I'm gonna go interface G0/0, and I'm gonna say IP. Right, this is a format. Now, how did we configure IP address to IP version 4 interfaces? So it is IP address. Now that is going to be IPv4 address, but if you want IPv6 address, it says you need to type IPv6 address, and then you give the address, whatever address that you want to give. So I say IP address 2001::1/64. You see that? You can give /64. It's very, very, very convenient. In IP version 4, it was very difficult. We wanted to give that slash notation, but it would never accept the slash notation. So here we are going to the modern way of representing IP addresses. So slash notation is accepted here, and we say no shutdown. Let's say do show, right? How did we do my favorite command? Show IP interface brief. That was the way we did for IPv4. Now how do we do for IPv6? Absolutely right, we just add IPv6. Like how did we do here? Everything IP we change with IPv6. So show IPv6 interface brief would give me the interface brief of IPv6 interfaces, right? So in this case, IPv6 address, if you can see that 2001::1 is an IP address that's configured on this, but also you see that there is a link local address that is auto generated, that is 290, and if you can see in the middle, FFFE has been padded to make this the EUI64 format. So we can go into this interface, configure terminal, interface G0/0, and let's give it another address. So I just wanted to show you how I mean, if I were to give in a normal IPv4, if I in an interface, if there's already an IP address and I say IP address and give another address, that old address gets overwritten, like we discussed earlier. So I'm going to say 2002::1/64 do show IPv6 interface brief, and you can see that both the IP address are still available on that interface, right? So that's the best part. Now let's say we want to change, for some reason you say you don't want the EUI64 format to be part of the link local address. How do we change that? You say IPv6 address FE80, right? All the link local should start with FE80, and I say 1, right? And remember, link local does not have a slash notation, so you don't have to put /64. All you have to say is link local, right? So remember, there is no slash for link local because link local is locally significant, right? So it only has to start with FE80, and if you want to manually put, you will have to type this link local at the end of the IP address, and you hit enter. And let's go back to show IPv6 interface brief, and you will see that the link local has been updated. Remember, a normal address it will add, but if it's a link local, there is going to be only one FE80 address, and hence that FE80, the old FE80, would be updated to the new FE80 address that you give, or the new link local address that you give, right? So this is how you automatically get a link local, and you manually get the link local address. So we saw how to get automatic link local, and we also looked at manual link local. Now, automatic IPv6 address. What is automatic IPv6 address? There are a few ways. One automatic IPv6 address is a stateful automatic IPv6 address. Now, when you say stateful, that is with a DHCP server. So if we have a DHCP server, right? And exactly how DHCP server works for IPv4, we discussed DHCP in one of our videos, so you know how DHCP works. So DHCP would assign an IP address to a device that wants a DHCP address, right? So that's a stateful auto configuration. Another way, let's say you have an address and you don't want to type an address to this interface, and you don't have a DHCP server, but you don't want to type an address, you just want it to automatically generate. We can go back and make use of this EUI64. That means anything that is not FE80, that can be an IP address. So I can say I want 2001 : and I want the EUI64 format, right? That's absolutely possible, and that is a way to automatically configure IP address, and we'll show you how to do that in a bit. And manual IP address configuration, like we did, we put that IPv6 and you give the address /64, and that is the manual IPv6 address configuration, right? So let me show you how to do the automatic EUI64 format, right? So now we are here, and we will configure IPv6 address using the EUI64 format. So how do we do that? So it's the same way as we configured the manual IP address. So IPv6 address, and we say 2010, whatever we want to give, : /64, and we say EUI64, and it should have, let's say, no shut, and do show IPv6 interface brief, and we see that it has generated 2010 with the same EUI64. So you see FE80, it uses the MAC address. It's exactly the same host part, but this is IP address, a unicast IP address, and this is the link local IP address, right? So this is how we do the manual, the automatic way of generating the IPv6 address. And the manual way, like we know, we can just put an IP address, and that becomes the manual way, right? Next, let's look at configuring IPv6. So we have this diagram. So I have a host here, I have a host here, and two routers and two switches, and then let's quickly configure this. So I'm going to open packet tracer. So we will look at three aspects. We'll configure IPv6 addresses. We have what we learned in the last slide, and we will ping those devices, and we will look some IPv6 troubleshooting commands. Alright, so this is what it is. I don't know if you all can see. I've also put the IP addresses, so I'm gonna... Right, so this is the exact requirement that is there in the presentation. So I have put those labels and the required IP addresses here. So let's quickly go here, and this device, we will go to IP address, and we will disable IPv4, and let's give a static IP address to IPv6. So that is 2001 : 11 : 1/64. Right, this is how you give in your Windows systems. So I'll go with the gateway. In this case, the gateway is going to be this one. So it's 2001 : 11 : 10, and we don't have to give a slash notation because it knows where it is, right? So that's done. Similarly, let's go here and do the same thing. This is all Windows configuration, so we don't have really concentrate much on this, and it's definitely not part of our scope of our syllabus. It was 2001:22:1/64, and our gateway is 2001:22:10, right? So that's also done. Let's get to this critical part now. So I'm going to quickly remove all the IP addresses. Interface G0/0, no IPv6 address, and hopefully everything should be good. Do show IPv6 interface brief. Yeah, it has taken down all the interfaces. So let us go to G0/1 and let's do the same command, no IPv4 addresses, and it should also be this do show IPv6 interface brief, right? So all the IP addresses have gone off, right? This down is because it's still not communicating. You see it's red because this interface is down. This is our old router which we used, and this is in no shutdown, or it's in no shutdown mode, and this is a new router we have not configured, right? So don't worry about that, we'll come back to it. So first thing, interface G0/0, what's the IP address that we need to give? We need to give this IP address. So IPv6 address 2001:120:1:1//64, right? So we have given this IP address. No shutdown. Interface G0/1 IPv6 address 2001:11:10/64, no shut. Brilliant. So this is also done. Let's go to router 2, and this is a new router. Enable configure terminal, and let's do the same thing. So let's go to interface G0/0 IPv6 address 2001:120:1:1:2/64, no shutdown. Interface G0/1 IPv6 address 2001:22:10/64. What's wrong? Oh, sorry. So these are the things. Right, so IPv6 address, that's done, and let's say no shutdown, and this interface is also up. So technically now everything is done, configuring wise everything is done. So let's go here and say do show IPv6 interface brief, and we see that there is a link local address that is configured and the required IP addresses are configured. Similarly, if I come here, I say do show IPv6 interface brief, and I see that the required IP address is configured and the link local address is also configured, right? So from this router, right, let us try pinging router 0 or router 0, router 1, whatever, right? Router 0, and this is router 1. So how do we do that? Just the regular way, ping let's say 2001:120:1:1:1, right? Will it ping? Absolutely, it will ping because they are directly connected. Will it ping the FE interface? So let's say this is G0/0, so this has the link local IP address. Will this ping the link local IP address? What do you say? Ping FE80:290:2BFF:FE 52:6901. What do you guys think? Will it ping? It's asking for an output interface. Why? Because this, for instance, let's look at this device, right? And we see that both the devices have the same link local address, and it's absolutely fine. All right, so this, if you see here, it's 6902, and I think that is a packet tracer, but if you do it on a regular device or GNS3, it would be the same IP address. FE80 and it'll have the same exact same link local IP address. So you need to always, whenever you're doing pinging on the link local address, you need to tell which local interface are we pinging from. So in this case, we're pinging from the gigabit Ethernet 0/0. So I'm going to say gigabit Ethernet 0/0 and it will ping. But if you try doing the same thing, and I'm going to ping the same ping the same thing using my other interface. So I'm saying gigabit Ethernet 0/1. Will it ping? Absolutely not, because like I said, the link local address is significant only to this interface, right? So it will not be able to ping this address on any other segment, right? So this is very, very critical that we need to understand. So let's look at some troubleshooting command. Like I said, show IPv6 interface brief. That's how you look at the show IP interface brief. We can look at show IPv6 route, right? Show IP route, show IPv6 route. So it's kind of easy, you know. All the commands that we did for IPv4, just replace it with IPv6, and most of the time that is the way you do that. I think Cisco has done a brilliant job in doing that. So it's very easy for you to learn IPv6 if you know IPv4, because the commands are very, very, very similar. So that's how you look at IPv4. So you can also look show IPv6 interface gigabit Ethernet 0/0, right? So it also gives you gigabit Ethernet IPv6 information. So it tells you global unicast address is this. It has joined FF02. Remember, these are multicast groups, and multicast, like I said, first multicast addresses start with FF, right? And it's like a radio signal. It's a station. This is a station where they've tuned into this now, right? They've joined this group. So any address, any packet that is coming to this destination, all these devices that is tuned to that group or join that group will receive that. So it's a multicast group that they've joined, right? MTU is 1500, ICMP error is limited to every 100 milliseconds, and all these things are the features of IPv6 interfaces, right? So these are the troubleshooting command in IPv6, right? So we have looked at configuring IPv6 address, we have ping IPv6 devices, we have ping, and we did IPv6 troubleshooting command. Now let me ask you one critical question. Now, can I from this device, can I ping this device? So from here, can I ping to this device? So let's try. I would go and say ping 2001:22::1. What do you guys say? Will it ping? Absolutely not, because it's very, very obvious that these devices don't have the route. This is exactly how it worked in IPv4. If there is no route that is specified between these two devices, they will not work, right? So you send this packet, it will come here. This packet will not know how to route to this network 2001::22, this network. It would not know how to route. So we need to give a routing, right? So we need to either do static route or we need to do dynamic route, right? So let's start with static route first, and then we will go to dynamic route. So how do we do static route? We can do static route in one way, where we could statically go configure that. So let's do it this way. Let us do this way. So how do we do in IPv4? We say IP route. So in this case, it will be IPv6 route, and then we will give the address where we want to route. What do we want to route to? So we want to route to 2001:22::0/64. How do we route? So we're telling this router, right? We're telling this router about this network. So this router, for it to reach this network, it needs to communicate, or rather send that packet to this interface. So these are the different way we can tell exit interface, or we can tell what is the IP address of the next hop. The IP address of the next hop will be 2001:120:1:1:1:2, right? And if you want to do admin distance, if you remember, we told you how we can change the admin distance of a static route. We can give that admin distance here, but we don't want to do that. Let's enter, and this device now will know how to route to this network. Similarly, now I'm going to go do that here as well. IPv6, so let's say config t IPv6 route, and I'm going to say 2001:11:0/64. and how does it reach there? It reaches through 2001:120:1:1:1. Right, so now can this device, this router, ping to this device? So let's start with ping 2001:22:10. Absolutely, it can ping. Then ping :1. Can it ping? It's going to do this, do this, do this, do this, do this, and it's not going to ping. Why? There should be a reason. I think this device 2001:22:1, right? This is the gateway, 2001:22:10. That seems to be all right. And let's see what this device is configured. 2001:11:10, 2001:11:1. It seems to be fine. So what's happening? What is happening? Right. The reason this is not working is because of IP routing. So I'm gonna come here and I'm gonna type this command, IPv6 unicast routing, right? I'm gonna do that same thing here, IPv6 unicast routing. Now will it work? Absolutely yes. So if you want to enable routing on these devices, you need to go to these devices and give this unicast routing command. So my mistake, I should have done this earlier, and that's how you do it. So unicast routing is enabled, and now these devices are absolutely communicating with these two devices, right? So that's how you do statically. Now if you want to do dynamically, we can make use of RIP. RIP has updated itself to accommodate IPv6, and that is called as RIP-NG, right? So let's make use of RIP-NG now. So let us go and remove the static routes that we configured. We say no IPv6 route, and I'm going to go here and do the same thing. I'm going to say no IPv6 routing. After I do this, I'm going to go again, look at the routing table, show IPv6 route. That is going to give me the routing table, and I say the same thing here, show IPv6 route, right? And routing table is here. So this routing table has no information regarding the 2001:22 network, so obviously routing will not happen. So now it is like before, it will not ping. It says destination host unreachable. That means that whatever that ping that you're sending from this PC is going here, and this device, if you can see 11.10, that is the router is telling the destination host is unreachable. That means I have no idea where you're trying to go. Perfectly fine. That's exactly the error message that you expect when you don't have a route in your routing table. Now we can enable RIP. So how do we enable RIP? The difference between RIP in IPv4 and IPv6 is, in IPv6 you go to a routing process and then you enable the network, but in this case you go to the interface and you tell that routing needs to do. So we go into this interface G0/0, and I'm going to say IPv6 rip, right? And I'm going to tell a word, so I can give any word. I can say NetworKing, and I will tell enable. So I'm going to say this interface G0/0 is enabled for IPv6 routing. Absolutely fine. That's the only command that is required. I'm going to go interface G0/1, and I'm going to put the same command, IPv6 rip networking enable, right? This networking, this word, or the word, is just a process ID, right? So it used to have in IPv6, this word is what identifies. So all the RIP routing protocols, it has to have the same name. The names need to match, and that's when it'll work. And the other device, let's say for instance this device, again it's the same way, configure terminal interface G0/0 IPv6 rip, and you give a name, and here you don't need to have the same name as the other router. This is a word that is significant, locally significant. Only this device you need to have a matching name, right? So I can say network, and I say enable, right? Again, interface G0/1, and I give the same command, and now routing should be enabled. Show IPv6 route, and this is IPv6, that's a routing table, IPv6, and show IPv6 route. This is IPv6 routing table, and you see that using RIP routing they have learned this network. So now will it work? Absolutely yes, it should work, because now this device knows how to route packets between this device. So one thing that is critical that you need to know, that if routing is enabled, you need to give in the global config mode IP unicast routing command, and that's when they will start routing packets between devices or between networks, right? So that is how you do static routing, and we make use of RIP NG, or the RIP next generation dynamic routing. Right, so we have learned a lot, so I would recommend all of you to watch this video a couple of times, because there are so many topics that we discuss, and we tried to I didn't want to have another IPv6 video, because there are so many more topics that we need to cover. So I wanted to finish in this video, and that's why I had to pack all this information in this one video, because IPv6, I think 2 videos should be good enough for CCN and IPv6, right? So if you have more doubt, or later if I think IPv6 topics, some of the topics might need one more video, I will obviously come back and give you another video. But for now, we're going to finish with IPv6. So we will start with topics, more routing videos like EIGRP and OSPFs. And what I'm going to do is, every time I do EIGRP or OSPF, if there is an IPv6 topic that we need to do, maybe I will do a video for IPv6 OSPF or an IPv6 EIGRP, right? Other than that, we will not be coming back to IPv6 video. So take the liberty to watch this video a few more times, watch the previous video also, and then you understand what IPv6 is as a whole. So thank you very much for watching, and if you like this video, hit that like button. If you did not like that video, you're free to hit that unlike button, right? So we live in a democratic world, right? So you are free to do whatever you want, but please subscribe to that channel, and this is a channel where we would be getting many more videos, not only on Cisco. We would have many more. I'm planning to get ethical hacking. I'm planning to get videos on web development. I'm planning to get on Java programming, C++ programming, Android application development, iOS application developments, and many more, right? We will be having many wonderful things happening in this channel, so don't forget to hit that like button. See you very soon. Stay tuned. Bye bye.